Okay, class, welcome to our video lesson 6, and today we're going to be talking about special cases with equations, and we're going to look at equations that have some different answers than we've been exposed to before. We're going to be talking about a no solution or infinitely many solutions. Our objective for today is we want to be able to solve special case equations. Now, I know you guys can solve all kinds of equations, you know, by hand using your Desmos calculator. Terms that we have today are simplify, intersection, parallel lines, and like terms. But before we start solving an equation, let's set one up for real world. I know you guys can solve it. It says, imagine you're taking an Uber while on vacation. The service charges $9 to pick you up and 45 cents per mile for your trip. Without knowing how many miles you are going, can you think of a linear equation to model your situation? I bet you can. Let us write it below using C for our cost and M for our miles we go. So let's keep it simple. Let's say we just go 1 mile. How much is that going to cost us here with 45 cents? Well, it's 45 cents per mile, so that's going to be 45 cents, right? Plus you add the $9 on it. That's to go 1 mile with the Uber is going to cost you $9.45. How about 2 miles and so forth? So let's see if we can write something. We're going to look here for our cost. So I'm going to write down C. We know just for the Uber driver showing up, they're going to get $9. And then we have to go ahead and add in there 45 cents times each mile we go. So if it's 1, that's where we get 45 and so forth. Now, we can shorten this a little bit and just slim it down. We can say 9 plus 0.45 m as long as the miles and is our m and c is our cost. So that's how we model a real-world situation with the equation. And you can replace those variables with numbers and find out your answer. So let's go on to example 1. Now, my guess is that you guys know how to do stuff like example 1. I'm going to go ahead and solve it by hand if you don't mind. So it says solve and check the following equations. It says -3 minus 2x equals -17. I'm trying to look for that x right there. It's not a good arrow, but there it is. So I've got to get rid of this -3 and this -2 right here that's multiplying with my x. So I'm going to start by adding 3 to both sides. Fair enough. I get -2x is equal to -14. Hopefully I didn't lose track of that negative sign. Nope, I didn't. And then I just have to divide by -2 on both sides. And I get x is equal to, oh, let me erase that there. X is equal to 7. Already has that in there. So x is equal to 7. I can check it real quick by plugging it in. I got -3 minus 2 times 7 is 14. So this whole term turns into 14. So it's -3 minus 14, which is -17. I can go ahead and lasso that guy up. Let's look at this problem here. It's got parentheses. I'm going to use the distributive property. I get 2x minus 8 plus 2x, all equal to 4. Hopefully you can read that. It's plus 2x. I have a 2x plus another 2x. That's going to be 4x minus 8 is equal to 4. Now it's starting to look familiar to me. It looks like a two-stepper here. I add 8 to both sides. Clean that up. I got 4x is equal to 12. Divide both sides by 4. And I got x is equal to 3. Let me check it here real quick. So that's 3. 3 minus 4 is -1. 2 times -1 is -2. Plus 2, not times x. 2 times 3 is 6. Is -2 plus 6? Is that 4? If it is, you can lasso that guy up. Now, example 2, let's revisit what we do with our Desmos calculator. So let's look at this problem. I'm going to grab my Desmos real quick. Here we go. Let me clear that stuff out of there. Move this Desmos over. Let's start from scratch. You guys remember that I'm going to take, and the sides are chosen up through the equal sign, so I'm going to take the left side and type that next to a y equal to, and then I'm going to take the right side and type that next to a y equal to. So that's what I'm going to try to do here real fast. You type with me. Grab your Desmos if you haven't done so. I got y equal 3 times a quantity x plus 2, close the quantity, minus another x. Let me grab another box here, type my y equal to in. I've got 2x minus 6. Whoa! Notice what I have here on my graph over here. Hopefully you guys can see it. What do you guys notice about that graph? Well, the lines, you got parallel lines. P-A-R-R-A-L-L-E-L. I have one too many L's in there. P-A-R-A-L-L-E-L. Parallel lines. Okay? So when do these guys intersect over here? Well, they don't. You guys know that parallel lines are not going to intersect. So we're looking for the intersection. That's where we find the solution. So if they don't intersect, we're not going to have a solution. So this is a no solution problem. So that's what it looks like on your Desmos if you have that first special case. All right, let's move this out of the way and go over here on the upper right of our notes, if we can. All right, let's solve this next one by hand up here. Here we go. It has 2x minus 7 is equal to 8 plus 2x. I'm going to pick on the little guy. We learned that lesson, right? I'm going to go ahead and subtract 2x from both sides. Clean that up. I got negative 7 is equal to 8. Well, wait a second. What happened to my variables right there? Okay? So what did you notice about the solution? Well, the variables are gone. Variables are gone. Okay? And is this correct right here? That's not true. And the equation's not true. So what do we do in that situation? Well, that's going to be a by hand case of no solution because we can't find what our x is. It's gone. Okay? And besides that, an important thing is it's not true. Okay? Now, the next problem here has our Desmos calculator back in action. So let's grab that again. See how we're going to do that problem. So I'm going to go ahead and type next to, I'm going to cheat up here a little bit. It's already got the 3 times quantity x plus 2. I'm going to put plus 2 on that top one. And then the bottom one down here, I'm going to have to do some typing. I'm just going to go in here and type 5 times the quantity x plus 2 minus 4. Did I do that one correctly? Let me double check everything. Oh, I got to put an x up here. Sorry, guys. Whoa! What happened to my lines there? What happened to my lines? Let me see. Let me click on this box and see where that other line is. Uh-oh, that's turning red. It's turning blue. So what you notice right here, guys, is when you graph this thing, what did you notice? The lines are on top of each other. Okay? So the lines are on top of each other. We write lines right there. So the lines are on top of each other. So how many points do they have in common? Okay? Well, they have infinitely many points in common. So that's going to be their solution. So they're going to be infinitely many solutions. Infinitely many solutions on that problem. So that's what that looks like. If you graph it, you have 2 lines that lay on top of each other, you have infinitely many solutions. Now, let's slide down here and see what we have left in our notes. Almost done. So, we have 2 special cases that we saw today. Okay? We have 2 special cases. Let me clear this out. Okay? We have a no solution, and we have infinitely many solutions. Solutions on there, so make sure you got the S on there. For no solution, you remember that our graph is going to be two parallel lines that aren't going to intersect. So when we look at our graph, there are two parallel lines. Or we get some type of equation that says like 7 equals 25, which is not true. Now, the second thing you saw was for infinitely many solutions. Infinitely many solutions. And when we graph those, the one line graphed, and then smack dab over top of it, another line graphed. So I'm going to sort of make this sort of squiggly in and out. So another line is right on top of each other. So that's what that looked like. Now, mathematically, if we solved it by hand, you would have those variables possibly drop out, and you would have something like 7 is equal to 7, or negative 14 equals negative 14. Or you might even have, if you do it differently, like 2x equals 2x, where that is always true. And if that happens, you have infinitely many solutions for the solution for that equation. So 2 special cases you learned about today. We'll get some practice here in a second. Thanks for watching.